Explain question number first, exercise 1.1 class 12th. Determines whether each of the following relations are reflexive, symmetric and transitive. First relation are in the set A is equal to braces of 1, 2, 3, dash 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 13, 14 defined as R is equal to braces of small bracket x, y 3x minus y is equal to 0. Second relation are in the set N of a natural numbers defined as R is equal to small braces of small bracket x, y is equal to x plus 5 and x is less than 4. Third relation R in the set A is equal to braces of 1, 2, 3, 4, 5, 6 as R is equal to braces of small bracket x, y, x is divisible y is divisible by x. Fourth relation R in the set Z of all integer defined as R is equal to braces of small bracket x, y, x minus y is an integer. Fifth relation R in the set A of human beings in a town of a particular time given by a R is equal to braces of small bracket x, y, x and y works at the same place. B R is equal to braces small bracket x, y, x and y live in the same locality. C R is equal to braces of small bracket x, y, x is exactly 7 centimeters taller than y. D R is equal to braces small bracket x, y, x is wife of y. E R is equal to braces of small bracket x, y, x is father of y. Solution start. First A is equal to braces of 1, 2, 3, dash 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 13, 14. R is equal to braces of small bracket x, y 3x minus y is equal to 0. Therefore R is equal to braces of small bracket 1, 3, bracket of 2, 6, bracket of 3, 9, bracket of 4, 12. R is not reflexive since bracket of 1, 1, bracket of 2, 2, bracket of dash bracket of 14, 14 is not belongs to R. Also R is not symmetric as bracket of 1, 3 is belongs to R, but bracket of 3, 1 is not belongs to R. Big bracket of is 3, small bracket 3 minus of 1 is not equal to 0. Also R is not transitive as bracket of 1, 3, bracket of 3, 9 is belongs to R, but bracket of 1, 9 is not belongs to R. Bracket of 3 into 1 minus of 9 is not equal to 0. Hence R is neither reflexive nor symmetric nor transitive. Second, R is equal to braces of small bracket x, y is equal to x plus 5 and x is less than 4 is equal to braces of small bracket 1, 6, small bracket of 2, 7, small bracket of 3, 8. It is clear that bracket of 1, 1 is not belongs to R. Therefore R is not reflexive. Bracket of 1, 6 is belongs to R, but bracket of 6, 1 is not belongs to R. Therefore R is not symmetric. Now since there is no pair in R such that bracket of x, y and bracket of y, z is belongs to R, then bracket of x, z cannot be belongs to R. Therefore R is not transitive. Hence R is neither reflexive nor symmetric and not transitive. Third, A is equal to braces of 1, 2, 3, 4, 5, 6. R is equal to braces of small bracket x, y. Y is divisible by x. We know that any number x is divisible by itself. So bracket of x, x is belongs to R. Therefore R is reflexive. Now bracket of 2, 4 is belongs to R, but bracket of 4, 2 not belongs to R. Therefore R is not symmetric. Let bracket of x, y, bracket of y, z belongs to R. Then y is divisible by x and z is divisible by y. Therefore z is divisible by x, which implies bracket of x, z is belongs to R. Therefore R is transitive. Hence R is reflexive and transitive but not symmetric. Fourth, R is equal to braces of small bracket x comma y, x minus y is an integer. Now for every x is belongs to z, so bracket of x comma x is belongs to R as x minus y is an integer. Therefore R is reflexive. Now for every x comma y belongs to z, if bracket of x comma y is belongs to R, then x minus y is an integer. Minus of bracket x minus y is also an integer, which implies bracket of y minus x is an integer. Therefore bracket of y comma x is belongs to R. Therefore R is symmetric. Now let bracket of x comma y and bracket of y comma z is belongs to R, where x comma y comma z is belongs to z, which implies bracket of x comma y and bracket of y comma z are integer, which implies x minus z is equal to bracket of x minus y plus bracket of y minus z is an integer. Therefore bracket of x comma z is belongs to R. Therefore it is transitive. Hence R is reflexive, symmetric and transitive. Fifth, A, R is equal to braces small bracket x comma y, x and y work at same place, which implies bracket of x comma x is belongs to R. Therefore R is reflexive. If bracket of x comma y belongs to R, then x and y work at the same place. So also y and x work at the same place, which implies bracket of y comma x is belongs to R. Therefore R is symmetric. Now let bracket of x comma y comma bracket of y comma z is belongs to R, which implies x and y are work at the same place and y and z work at the same place, which implies x and z are work at same place, which implies x comma z bracket of x comma z is belongs to R. Therefore R is transitive. Hence R is reflexive, symmetric and transitive. B, R is equal to braces small bracket x comma y, x and y live in the same locality. Clearly bracket of small bracket of x comma y is belongs to R, as x and x is the same locality. Hence therefore R is reflexive. If bracket of x comma y is belongs to R, then x and y live in the same locality, which implies y and x live in the same locality, which implies y comma bracket of y comma x belongs to R. Therefore R is symmetric. Now let bracket of x comma y is belongs to R and bracket of y comma z is belongs to R, which implies x and y is live in the same locality and y and z is live in the same locality. So x and z is also same locality, which implies bracket of x comma z is belongs to R. R is transitive. Hence R is reflexive, symmetric and transitive. C, R is equal to braces of small bracket x comma y, x is exactly 7 cm taller than y. Now small bracket of x comma x is not belongs to R, since human beings x cannot be taller than himself. Therefore R is not reflexive. Now let bracket of x comma y is belongs to R. X is exactly 7 cm taller than y, but y is not taller than x. Then y is exactly 7 cm shorter than x. Therefore x is not symmetric. Now let bracket of x comma y comma bracket of y comma z belongs to R. X is exactly 7 cm taller than y and y is exactly 7 cm taller than z, which implies x is exactly 14 cm taller than z. Therefore x comma z not belongs to R. Not belongs to R. Therefore R is not transitive. Hence R is neither reflexive nor symmetric nor transitive. D, R is equal to braces small bracket x comma y, x is the wife of y. Now bracket of x comma x not belongs to R, since x is cannot be be the wife of herself, therefore R is not reflexive. Now let bracket of x comma y is belongs to R. X is wife of y. Clearly y is not wife of x, therefore bracket of y comma x not belongs to R. Indeed, if x is wife y, wife of y, then y is the husband of x. Therefore, R is not transitive. Let bracket of x comma y comma bracket of y comma z is belongs to R. X is the wife of y, and wife y is the wife of z. This case is not possible. Also, that does not implies that x is the wife of z. Therefore, bracket of x comma z is not belongs to R. Therefore, R is not transitive. Hence, R is neither reflexive, nor symmetric, nor transitive. R is equal to braces of small bracket by x comma y. X is a father of y. Bracket of x comma x not belongs to R, as x cannot be the father of himself. Therefore, R is not reflexive. Now, let bracket of x comma y belongs to R. X is the father of y, but y cannot be father of x. Indeed, y is the son or daughter of x. Therefore, bracket of y comma x is not belongs to R. Therefore, R is not symmetric. Now, let bracket of x comma y is belongs to R, and bracket of y comma z is belongs to R. X is the father of y, and y is the father of z. X is not the father of z. Indeed, x is the grandfather of z. Therefore, bracket of x comma z is not belongs to R. Therefore, R is not transitive. Hence, R is neither reflexive, nor symmetric, nor transitive. That is the answer.